Assalamu alaikum. This is Sabi Alam Chaudhuri from um, Group 4. So today we're gonna present our second draft on the topic identification of iris flower varieties through machine learning techniques. So as you can see, for our outline, we have data acquisition and preparation, choosing the model, implementation and of cross validation, and utilizing the confusion matrix. Let's talk about the data acquisition and preparation. Initially, we sourced the iris flower dataset from the UCI machine learning repository. This dataset encompasses 150 samples distributed across three distinct iris species: Setosa, versicolor, and virginica. Following the collection of the dataset, it was imported into our machine learning models. Um, for this import process, we utilized the scikit-learn toolkit, especially employing the load iris function from scikit-learn's dataset module. This function was executed to load the dataset and store the returned value in a variable named iris. Subsequently, we assigned various attributes within the iris dataset. These attributes include the data itself, the names of the feature and target, and so on. The target names in the iris dataset corresponds to the classes, namely Setosa, Virginica, and Versicolor. The feature names represent the dimensions of the flowers, such as sepal length, petal length, sepal width, and petal width. Next, the dataset was partitioned into training and testing subsets. We allocated 40% of the dataset for testing, while the remaining 60% reserved for training. Additionally, we set the random state parameter to 0. It's important to fix the random state to a specific number to ensure consistent results across the multiple rounds of the model. This consistency is crucial for accuracy analyzing the model's performance. Without setting the random state, each execution of the model might yield varying results, complicating the process and of the accuracy assessment. Now let's talk about the graphs we see here. We have like four graphs which was coded through this. Here we basically what we did here was we just read the iris dataset from CSV.
Hello everyone, Assalamu alaikum. This is Fairuz Tasnim Prapti. As we navigate through the intricate process of developing a predictive model for species prediction, we find ourselves at a critical juncture. Choosing the model. In this phase, our journey is guided by the versatile Scikit-learn toolkit, a companion that facilitates the implementation of three distinct classifiers. SVM, Support Vehicle Machine. First on our list is the Powerful Support Vehicle Machine or SVM. This technique proves effective in classifying both linear and nonlinear datasets. Leveraging a nonlinear transformation mapping, SVM projects our original training data into a multidimensional space. The key lies in searching for the best dividing subspace constructed with a set of vectors. In the context of our iris dataset, each data point finds its place in an n-dimensional space where n represents the number of features. Our implementation utilized the SVM algorithm through the SVCF function from the scikit-learn, achieving an impressive accuracy of 98%. Now talking about the logistic regression model. We turn our attention to the logistic regression model as a mathematical process rooted in the statistical analysis. This method is adapted examining datasets with one or more independent variables influencing the outcome. In the realm of iris flower dataset, logistic regression becomes a tool for segmenting data based on the length and width of the iris flowers. Renowned for its efficiency with binary and categorical data, logistic regression employs a sigmoid function. It functions effectively even with the larger datasets. We imported the logistic regression action from Skeleton and achieving an accuracy of 97.33% in our evaluation. Now, we will be talking about the k-nearest neighbor classifier. Our trilogy of classifying concludes with the straightforward and data-reliant k-nearest neighbor algorithm. Operating solely on the training dataset, KNN searches for the k most similar instances to generate forecast on newer data. Classification is based on the similarity measured by the distance between instances. For our implementation, we turn the k-neighbor classifier function from the skeletal neighbors, achieving an accuracy of 96.67% based on the model's predictions. Each classifier was meticulously chosen and evaluated for effectiveness in predicting the correct species in iris flowers. Our consideration extended to factors such as feature dimensions and similarity measures, ensuring a comprehensive exploration of the model's landscape. Thank you for accompanying us through this phase of our journey where precision and efficiency intertwine with the artistry of machine learning.
Assalamu alaikum. Hello everyone. This is Ashikuজ্জামান Udri, ID 20301268. Our topic is identification of iris flower varieties through the machine learning techniques. In this second draft, my part is implementation of cross validation. Cross validation is a method to employ to set the aside of specific portion of a dataset which is not used to train the model. This reserved sample is then used to validate each subset of the training data. During this validation process, the reserved sample is initially set aside and the model is trained with the remaining part of dataset. Subsequently, the reserved sample either from the test or the validation set are utilized to the effectiveness of the model performance. There are three steps in cross validation. Initially a side of portion of the dataset as simple data used the remaining part of dataset to train the model. 3. Employ the reserved sample from the test set, access the model performance. A model is that uses favorable result with this validation data is considered effective. One of the primary benefit of cross validation is obtaining a more piece of result estimate from the sample accuracy. It enhance the efficiency and the effectiveness of the model performance. The accuracy level of SVM, KNN and logistic regression classification method which applied to the iris dataset. We compared the accuracy result with and without the cross validation process. Our analysis related the accuracy of the model improves when the cross validation is implemented as the opposite scenarios where it is not used. Thank you.
Utilizing the confusion matrix. The confusion matrix serves as a tabular representation to evaluate the efficiency of a classification model. This matrix utilizes text data where the expected output levels are already established. It provides a straightforward indication of whether the model's predictions are accurate or not. And it aids in pinpointing any error made by the model. The model's accuracy score was determined using the confusion matrix. In the context of the iris dataset, the first four columns represents the dataset's attributes. The fifth column denotes the target, indicating the classification level for the given sample data. Thank you for the for listening my presentation.